These example problems want to target, they always try to target like a specific part about probability that you got to think of. To the mind that really understands probability, you don't separate them. You just lump them all together. So I'm just going to talk through this with you guys, and hopefully it makes a lot of sense to you before I give you guys a technical lingo. Now, I think the key word here is overlap. If there's overlapping, you got to make sure you recognize that. And there's overlapping on this one. Okay, so there's a deck of cards that has 52 playing cards. Now, this problem assumes that you guys know what's in a deck of cards. It doesn't give you the explanation, like if this was a state test, they would explain it and everything, but it's not. All right, so in this deck of cards, what is the probability that the card that you choose is either a heart or a face card? So we have one event, and that is you choosing one card. What is the probability of you choosing a heart card? Just a heart card. Let's think about that for a sec.
13.
How many different suits are there? Heart is a suit.
4.
Then there's diamonds, spades, and clubs. So there's 4 suits. How many heart cards are there? 13. Now you could think of it like this. You could have said like, oh, it's 13 over 52. But how many of you guys thought 1/4? Anybody? If you divide the top and the bottom by 13, you would get 1/4. So this is the probability. I'm going to keep it with the 52 on the bottom. This is the probability of getting a heart card. What is the probability of getting a face card? Now it says or, so I'm going to add. It says or. What's the probability of getting a face card? In each suit, that's correct. In each suit, there's 3 face cards. And there's 4 suits, so that means there's 12 face cards total out of the whole deck. Okay? But if we just add these together, that wouldn't be correct because there's overlap. Are there cards that are heart and face card? Like, are there cards that are being counted twice? 3 of them. So now you got to take those away because you don't want to get counted twice. Now you have a inaccurate probability. So we add these together. 52's on the bottom. You get 22 on top, which simplifies to 11 over 26. That's your probability. Now you can make this into a decimal or a percent, but it's not necessary. This is when you got overlap. So what we have here is the probability of this and or this happening. Okay? Probability of event A and the probability of event B. And so what you do is you find the probability of event A, which is what we did right there. And then you add to that the probability of event B happening, which is right there. And then you take away from that the probability of event A and, using this union sign, and B happening. So what is A and B happening? That's being a heart card and a face card. And that is what this fraction is right there. So that's how you find the probability of 2 events happening that are that have overlap. Yeah.